we got you. Wherever you want to from, we got what you need. Total online class, we got you.
Good day, viewers all over the world. You are welcome to Toydel online class. Today, we want to look at some of the applications of differential calculus. That is, some of the applications of differentiation. So there are so many applications of differentiation, but today we are starting with the first application, which is under tangent and normal to the curve. Under tangent and normal to the curve. So at any point on a curve, the derivative divided by x at that point gives the gradient of the tangent to the curve. That is, the differentiation at any point on the curve, the differentiation at that point gives the gradient of the tangent at that point. So please let's note that. And a straight line, if you have a straight line that is perpendicular, a straight line that is perpendicular to the tangent of that point of contact to the tangent of the curve is called normal. So I want us to get the difference. When we talk about the tangent simply means at any point on the curve, the derivative divided by x at that point gives the gradient of the tangent to the curve. That is, if you have a curve, let me quickly explain. If you have a curve, let's say this is the curve, and a line that touches any part of the circumference at a point, this line is called line of tangential. That is, if you have a curve, if there is a line that touches any part of the circumference, that point of contact is called point of tangential. That line that touches that curve is called the line of tangential. So what we're trying to say in this case is that the derivative at this point now, the rate of change of y with respect to x at this point gives the gradient of the tangent at this point. So if you now have a line that is perpendicular, if you have a straight line that is perpendicular to the tangent at this point of tangential to the curve, this line is called normal to the curve because that line is perpendicular, makes an angle 90 to the curve. So I want us to understand this. Then I want to talk, for you to have proper understanding about this, I want you to check my video on equation of a straight line. So where we talk about distance between 2 points, midpoint of a line, just check my videos on the equation on Cartesian coordinates. So that will be of assistance. That will greatly help us to be able to understand this concept. So that is that about that. So we should note that a straight line that is perpendicular to the tangent at the point of contact of the tangent to the curve is called normal to the curve. So let me just use example to explain further. Example where we have find the equation of the tangent. Find the equation of the tangent and the normal to the curve. Y is equal to x squared minus 3x minus 4 at x is equal to 1. That is what we are given. We must understand we have to find the equation of the tangent and the normal to the curve. Y is equal to x squared minus 3x minus 4 at x equal to 1. So what do we do here? We are given y as x squared minus 3x minus 4. Then for us to be able to find the tangent, equation of tangent to this curve, there's need for us to find the y dx. That is the derivative at that point. Then if we differentiate this, we are going to have 2x minus 3. That is what we are going to get. Then we go ahead and find, we substitute at this point x equal to 1. We substitute for the value. So the y dx at x is equal to 1 is going to give us, when we substitute at x, this value at x equal to 1, we are going to have it to be 2 into bracket x is 1 minus 3, and that will give us 2 minus 3. That will be minus 1. So how do we get the equation of tangent to the curve? We just say if m, let m equal to the gradient. Let m equal to the gradient of the tangent. If we represent m as the gradient of the tangent at s is equal to 1, then m is equal to minus 1. That is, we were able to get this. This is the y ds, the derivative. But at that point on the curve, s equal to 1. So this will represent our gradient. That gradient is m is equal to 1. So from there we continue. We continue from there. So at the point s is equal to 1, what is the value of y? At point s equal to 1, what is the value of y? Y will be equal to, of course, we know the value of y is s squared minus 3s minus 4. So at point s equal to 1, y will be equal to 1 squared minus 3 into bracket 1 minus 4. This is 1 minus 3 minus 4, and that's going to give us minus 6. That's minus 6. So that's what we are going to get. So the equation of the tangent, at that point s equal to 1 is going to give us, this is what the equation will give us. We know the coordinate now. We know the coordinate to be, the coordinate at that point is 1 comma minus 6. So the equation to the tangent at that point is going to give us y minus y1 is equal to m into bracket x minus x1. Let me quickly explain this. Now, this equation is equation of a straight line when you are given the tangent and 1 point. Please, you can check my video on equation of straight line. There are 3 forms of equation of a straight line. We have when you are given tangent and intercept form, when you are given the gradient and 1 point form, then when you are given 2 points, there's a way you rewrite the equation of that straight line. So the equation of the tangent at that point x now, we've gotten the value of y, so we know the coordinate at that point is given as this. Then what do? We now substitute for this will be x1 and this will be y1. We substitute, this will be y minus 6 into bracket, we have gotten the value of m to be minus 1, the gradient minus 1 into bracket x minus 1. At the end of the day, we have y plus 6 to be equal to minus x plus 1. Then we have y will be equal to minus x minus 1 plus 1 minus 6. Then we have y to be equal to minus x minus 5. That's what we are going to get. That's the value of x. Or you can say y plus x plus 5 equal to 0. So this will represent the equation of tangent. So it's going to represent the equation of tangent to the curve. So the equation of tangent to the curve is going to give us what we have there. So this will represent the equation of tangent to the curve. So once we know the equation of tangent to the curve, then we can go ahead and find the equation of normal to the curve. So this is the equation of tangent to the curve. So once we know that, then we can say if m prime, we denote m as the gradient to the tangent. So let's denote m prime is the gradient. Let this one be the gradient of the normal to the curve at x equal to 1. Then m multiplied by m prime is going to give us minus 1. Please check my video on the gradients of 2 lines. There are 2 conditions. If the 2 lines are excuse me, if the 2 lines are parallel, their gradients will be equal. But if the 2 lines are perpendicular, the product of their gradients is going to give us minus 1. From my explanation, if this is the equation of tangent to the curve, the equation of normal to the curve will be perpendicular to equation of tangent to the curve at that point of tangential. So in this case now, the product of equation of tangent to the curve, the gradient of equation of tangent to the curve and the gradient of equation of normal to the curve is going to give us minus 1. Why will that give us minus 1? Because the 2 lines are perpendicular at that point of tangential. So please check my video on the gradients of 2 lines. So this is what we are going to get. Then we can make m prime the subject of formula. It will be minus 1 all over m. Then this will be minus 1. What is the value of m? We've gotten the value of m to be minus 1. That will be divided by minus 1, and it's going to give us 1. So the gradients of tangent, the gradients at the normal to the curve will be 1. That is what we are going to get. Will be 1. Then the equation of the normal, at the point x is equal to 1 is, that will now be, of course, we have gotten the value of x1 y1 x1 y1, we have gotten that to be 1 and minus 6. So the equation will now be y minus y1 is equal to m prime into bracket x minus x1. That's what we are going to get. So from there we have y minus 6 to be equal to m prime now, which is the gradient of normal. Gradient to the normal is 1 into bracket x minus 1, so that we have y plus 6 to be equal to x minus 1. Then at the end of the day, we have y to be equal to x minus 1 minus 6. That will be x minus 7. Finally, the equation of the normal at that point to the curve will be y is equal to x minus 7, or y minus x plus 7 equal to 0. So that will be the equation to the normal. So I just want us to note that when we have the equation of tangent and normal, equation of tangent to a curve and normal to a curve are perpendicular to each other. So we take one more example. Let's take one more example on the applications of differential calculus to tangent and normal to a curve. Let's take another example. Find the equation of the normal to the curve y is equal to 6 minus 2x plus 3x squared minus 2x cubed at x equal to 0. Of course, if you are talking about the curve could be quadratic. That is when you have the highest degree to be 2. In this case now, the highest degree that we have is 3 minus x cubed. So that is the highest degree that we have. So how do we find the equation of normal? To find the equation of normal to this curve, we'll first find the gradient of the tangent to the curve. We cannot find the equation of normal directly. We'll first find the equation of gradient of tangent to that curve before we can go ahead and find the equation of normal. So even if we are not asked to find the equation of tangent to the curve, it is compulsory to find the equation of tangent to the curve before we can go ahead and find the equation of normal to the curve. So we say we will first find the gradient. We first find the gradient of tangent to the curve. That's the first thing to do. To the curve. That's the first thing to do. We know y is equal to 6 minus 2x plus 3x squared minus 2x cubed. So we go ahead and find the dy dx, the derivative. The differentiation of constant is 0, so that cancels out. Then we have minus 2 plus 6x, then minus 6x squared. This is what we are going to get. Then that's what we are going to get. Then we substitute dy dx at s equal to 0. We need to check that as s equal to 0. So if we do that, we are going to get minus 2 at s equal to 0. Here will be 0, this place is 0. So that is going to give us minus 2. It's minus 2 that we are going to get. So if m now, let's say if m is the gradient, of the tangent, at x equal to 0, then m is equal to minus 2. So we have gotten the gradient. Of tangent to the curve. So we got to m is equal to minus 2. So if you have gotten the gradient of tangent to the curve, then we can go ahead and find the gradient of normal by using the formula. So at the point s equal to 0, let's find the coordinate. At point s equal to 0, y will be what? Y will be 6 minus, that's the value of y, 2x plus 3x squared minus 2x cubed. So at point s equal to 0, y is going to give us 6. Every other thing will be 0, because when you substitute, it will be 0. Everything will be 0. Minus 2 into bracket 0. So y will be equal to 6. So the coordinates x1, y1 in this case is going to give us 0, 6. That will be the coordinate. So since we now know the coordinates, we can go ahead and find the gradient to normal. We know the gradient to tangent. So the product of the gradient to tangent, let's say let m prime represents the gradient to normal to the curve. Let this represent the gradient of normal to the curve. So the product of the two, this m is the gradient of to tangent multiplied by m prime, which is the gradient to normal, because equation of tangent and normal are perpendicular, will give us -1. That's going to give us -1. Then m prime will not be -1 all over m, which is same thing as -1. We have gotten the value of m in this case to be 2. That will be -1 all over 2. So we have gotten that to be half. So the gradient to normal will be this. Then the equation of normal, to the curve, the equation of normal to the curve at the point x equal to 0 and y equal to 6 is y minus y1 equal to m into bracket x minus x1. Then from there, we are going to get y minus 6, that is 6, is equal to, no, that will be 1 all over m. This gives us 1 over m, because this is m prime. Let me just put m prime here. The equation to normal is m prime. So an m prime is m prime. We have got the value of m prime to be -1 all over 2 into bracket x minus 0. So we have y minus 6 equal to minus x all over 2. That's what you get. It will be minus x all over 2. Then 2 can come here. We have 2 into bracket y minus 6 equal to minus x. So we have 2y minus 12 equal to minus x. So we can have this to be 2y to be equal to minus x plus 12. Or we say 2y plus x minus 12 equal to 0. So this represents the equation of normal to the curve. So I would love to stop here. But before I stop, I want to refer us to my videos on the angle of slope, the equation of a straight line when we have one coordinate and we are given the gradient. Please just check my video on coordinate, Cartesian coordinates generally, in order to have in-depth understanding about all this equation of a straight line when we have two lines that are parallel, m1 equal to m2, and when they are perpendicular, you have m1 multiplied by m2 to be equal to -1. So I'd love to stop here because of our time. Thank you and God bless you.